Welcome to Sci Discovery Chronicles, where today we embark on a mind-bending journey into one of the most mysterious and revolutionary fields of science, quantum computing. Imagine a world where computers can solve problems that would take classical machines billions of years to crack. A world where information exists in multiple states at once, and where the very laws of reality seem to bend and twist at the atomic level. But what makes quantum computing so powerful, and how can it transform our future? Stick with us until the end, because the answers to these questions will challenge everything you know about technology and the nature of reality itself. Let's start with the basics. What exactly is quantum computing? To answer this, we need to first understand the key difference between classical and quantum computers. Classical computers, the ones we use every day, process information in binary ones and zeros or bits. A bit is like a light switch. It can either be on or off, 1 or 0, but never both at the same time. Everything from smartphones to supercomputers runs on this basic principle of binary code. But quantum computers are different. They operate using the strange and fascinating principles of quantum mechanics, the physics of the incredibly small. In the quantum realm, particles can exist in multiple states at once, a phenomenon known as superposition. So instead of a bit being limited to just a 1 or a 0, a quantum bit or qubit can be both at the same time. This seemingly small difference is what gives quantum computers their incredible power. Superposition and qubits, the power of being into places at once. At the heart of quantum computing lies the idea of superposition. Imagine flipping a coin. In the classical world, the coin can either land heads or tails, but in the quantum world, the coin is spinning in such a way that it's both heads and tails simultaneously until you observe it, that is. This is what happens with qubits. A qubit is like our spinning coin, but instead of just heads or tails, it can represent both at once. This ability allows quantum computers to process a massive amount of information all at once. Instead of handling just a possible outcomes like a classical bit, a qubit can handle many more combinations at the same time, drastically speeding up computation. To put this into perspective, imagine you're trying to find your way through a maze. A classical computer would explore each path one by one, testing each option until it finds the correct route. A quantum computer, on the other hand, can explore all paths at the same time, finding the solution exponentially faster. Quantum entanglement, the spooky force of connectivity. Another mind-boggling phenomenon in quantum computing is entanglement, something Albert Einstein famously called spooky action at a distance. When qubits become entangled, their states become linked in such a way that the state of one qubit instantly determines the state of the other, no matter how far apart they are, even if they are light years away. This interconnectedness allows quantum computers to perform computations that are exponentially faster and more efficient than classical computers. When qubits are entangled, they work together in perfect synchrony, exponentially increasing the processing power of the system. Entanglement gives quantum computers an edge in solving problems like factoring large numbers, something classical computers struggle with. This has enormous implications for fields like cryptography, where quantum computers could potentially break even the most secure encryption methods used today. Quantum gates, building a quantum circuit. Just like classical computers use logic gates to process bits, quantum computers use quantum gates to manipulate qubits. But instead of simply switching a 1 to a 0, quantum gates take advantage of superposition and entanglement to perform complex operations. Quantum gates allow qubits to interact and transform in ways that classical logic gates cannot. These gates can create entanglement between qubits, perform rotations to change the state of a qubit, or measure the outcomes of quantum states. By carefully arranging quantum gates, scientists can create quantum algorithm sets of instructions that solve specific problems. One of the most famous quantum algorithms is Schur's algorithm, which allows quantum computers to factor large numbers exponentially faster than classical computers. This has huge implications for cybersecurity because the encryption systems we currently rely on could one day be cracked by quantum computers running algorithms like this. The quantum advantage. Why it matters. So, why is quantum computing such a big deal? The answer lies in its ability to solve certain types of problems that classical computers simply cannot. This is known as quantum advantage. Quantum computers are particularly good at solving optimization problems, which involve finding the best solution from a large set of possible solutions. These problems appear in areas like logistics, financial modeling, climate simulations, and drug discovery. For example, consider trying to design a new drug. A classical computer might take years to simulate all the possible molecular interactions between different chemicals. But a quantum computer could perform the same simulation in a fraction of the time, opening up new possibilities for medical breakthroughs. Another example comes from the field of artificial intelligence. Quantum computers could revolutionize machine learning by quickly analyzing massive datasets, allowing AI systems to learn and adapt faster than ever before. The challenge is ahead. But while the potential of quantum computing is staggering, we're still in the early stages of development. Building a quantum computer that can outperform classical computers in a wide range of tasks is incredibly challenging. One of the biggest hurdles is quantum decoherence, the tendency of quantum systems to lose their quantum properties when they interact with their environment. Even the slightest disturbance, like a change in temperature or a stray electromagnetic wave, can cause a qubit to lose its state. This is why quantum computers must operate in extremely controlled environments, often at temperatures close to absolute zero. Scientists are also working on developing error correction codes to combat decoherence and make quantum computers more reliable. The future of quantum computing, despite the challenges, the race to build practical quantum computers is well underway. Companies like Google, IBM, and Microsoft are investing heavily in quantum research, and we've already seen some breakthroughs. In 2019, Google announced that it had achieved quantum supremacy, the point at which a quantum computer can perform a task faster than the best classical computer. While this milestone was met with some skepticism, it marked a significant step forward in the development of quantum technology. As we look to the future, it's clear that quantum computing has the potential to revolutionize many industries, from healthcare to finance to environmental science. But what's even more exciting is the possibility that quantum computing could unlock new insights into the fundamental nature of reality itself. After all, the principles that make quantum computing possible, superposition, entanglement, and decoherence, are the same principles that govern the quantum world. A quantum leap into the future. As we wrap up our journey into the mysterious world of quantum computing, one thing is clear: we are standing on the brink of a technological revolution that could reshape the way we solve some of the most complex problems facing humanity. From cryptography to drug discovery to understanding the universe itself, quantum computing holds the promise of unlocking doors that have been closed for centuries. But while the potential is enormous, we are just beginning to scratch the surface. There are many challenges ahead, but with each new breakthrough, we come closer to realizing the full power of quantum computers. So, where will quantum computing take us next? The possibilities are as limitless as the qubits in superposition. Thanks for watching Sci Discovery Chronicles. If you found this dive into the future of technology as fascinating as we did, be sure to like, subscribe, and hit the notification bell so you won't miss our next exploration into the world of science. Until next time, keep questioning, keep exploring, and stay curious.